HoangANh NGUYEN, and this is my movie recommendation system. For the assignment, I decided to use the collaborative filtering method because it is known as the most well-known and effective solution for a suggestion system. The algorithm I'm using today is KNN, and as you can see, I have three different approaches in my workflow, and each resulting in a separate set of results. The first approach is actually inspired by an article called Data Science Blockathon, in which the author used the item-based collaborative filtering algorithm. And first, we import the data set we will be using into NAM, then merge them together into a unique data frame. Here you can see that some attributes such as timestamp is excluded. In the articles I found on the internet, the author also suggested to use Python for the system creation, but I adapted the similar workflow and employed Python script for the task that name KNIME cannot finish. Here you can see that the user ID number 1 have watched movie 31 and 2455, but they haven't rated movie 1 or 2 or 3 or rate at all. So therefore, to make things easier to understand and work with, I make a pivot table where each column represents each unique user ID and each row presents each unique movie ID. Now we can see that our table has some missing data, and we're gonna fix that and input the question mark with 0 for the next step. The next step is to clean data noise by verifying quality movie and trustworthy users. We wouldn't want that were rated by a small number of users because it's not credible enough. And also, we also don't want users who have rated only a few items. I have to admit that I actually wanted to do this step with KNIME not only, but I found it's very challenging and actually a little bit beyond my intellectual capacity, so I gave up on trying and decided to cheat with Python. So I employed a Python script to help me reduce the movie that have less than 10 rate and user who have voted less than 15 movie. And once the table dimension is reduced, I use Python script to calculate the average rating, the number of rates of each movie, thus employing KNN algorithm to finalize the system. And this is the result on Tableau dashboard. Going back to KNM, my initial thought was, is the pivot table really needed? So I tried a second approach. This time, after merging the data sets, I used the exact same Python script to calculate the average rating to know the preference percentage of each movie, thus calculating the distance and compute similarity with the cosine distance metric just like the first method. And here is the table on Tableau. Here, if because the user number 4 has voted for the movie 10 Things I Hate About You, the KNN algorithm suggests that they maybe also like Toy Story. It's the same result for the approach number without the pivot table. The third approach was entirely out of curiosity. In approach 1 and 2, I excluded gender from computing the similarity in the pattern, so this time I include it to see if the generated results show any different. The third solution found in This workflow was the best I can do because I have tried another algorithm, for example, decision tree and content based collaborative filtering. I have learned a lot during and after this project, and indeed, I think the process of figuring out which algorithm to use, how to deal with unexpected challenges such as a messy pivot table, or the process of how to configure the node are equally challenging and time consuming. Until I was panicking a lot, especially when the whole workflow was gone due to some mysterious errors. I find this task is really interesting, and this is a very valuable experience that I have this semester.